Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. I am so happy to be back with you for Wednesday math night. I took about a month off. We had our first baby boy. We had our first kid, actually. And so I was off for about a month. But I am back, and I'm so happy to be back with you guys. Priya did an amazing job covering for me for the last 4 weeks. So shout out to Priya. Thank you so much. On Wednesdays now, instead of 7 to 8, we are now here from 6 to 7 every Wednesday. So I'm so glad that you are joining. Before we get started, I always like to read the room and see who's here. So if you could comment in the comment box where you're from, what test you're prepping for, that would really help me because it allows me, even though the test questions or the questions that I've developed are set in stone, it helps me know like what direction to take our rabbit trails as I'm explaining those questions to you. So where are you from? What test are you prepping for? And I know spring break is coming up. So do you have any big plans for spring break? The only plan we have is snuggling with our little boy. So that's it. He was 1 month a couple days ago. Hello, Renee. K through 6. Awesome. Like Dr. A said, the problems that we have are going to span from pre-K through 12th grade. And I like to take suggestions. So if you have a specific area that you want me to focus on in future upcoming sessions, let me know, and I will absolutely make sure I include problems about that in the upcoming weeks. I know some of you commented in the last few weeks when Priya was there, or like the last week I was there. If you did, I apologize. Just let me know again because I lost those comments. So if you have something that you want me to focus on, linear equations, geometry, a specific domain in geometry, just let me know and I will definitely make sure that I tailor the questions to that. Hi, Anna Marie. Hey, Laura. It's nice to see you all. And Sean was here a little bit earlier. I'm so happy that you guys are all here. So let's get started. So Sarah is teaching her students about patterns. Which of the following reflects an ABCA pattern? This is definitely going to be a question that is specific for our pre-K through 3 test takers. So Sarah is teaching her students about patterns. Which of the following reflects an ABCA pattern? Like I said, we're going to go over questions from pre-K through 12. So while this is a pre-K problem, we will definitely get into some harder content. ABCA is just a pattern where we have one kind of shape or letter or number, and then another one, and then another different one, and then we go back and repeat that A. I saw a question, is this starting at 7? No, we started at 6. Normally we do start at 7, but we've changed the time moving forward, and we are starting at 6 o'clock now. So we will be from 6 to 7 live, but it will be on our Facebook page for you to watch at 7 o'clock if you want to watch it at 7 instead. So if we have an ABCA pattern, let's go ahead and go through each of these patterns and identify them. If a blue circle is A, I'm going to label the next different one a different letter. So yellow would be B, but now I'm back to blue circle. So if the first blue circle was A, this would be A. So this is an ABAB pattern, not our option. This is going to be A, B, C, and then yellow is B. That's not our ABCA pattern either. A, B, B, A. Nope. A, B, C, A. We just found our winner, and that would be our answer. Very straightforward. Understanding patterns is one very critical thing for our pre-K through 3 people. Another thing that a lot of people don't realize is on the pre-K through 3 assessments is symmetry. You got to know about vertical and horizontal symmetry. We're not going to go over that today, but for my pre-K through 3 people, that's a concept that oftentimes gets overlooked on that pre-K through 3 assessment. All right, let's move right along. Problem 2. Malachi is working on representing numbers in multiple ways. He says that the number 248 can be represented in all of the ways below. Which of the following representations is incorrect? So it looks like the majority of you who are here right now in this moment are K through 6, except for Anna Marie, who's 6 through 12. Anna Marie, this is going to be critical for you to understand just different representations, but this question was formatted for our K through 6 people. So this is going to be a K through 6 or pre-K through 3, definitely an elementary level problem. So if we're looking at the number 248, really understanding place value is critical here. This concept is taught in depth in 2nd grade in the state of Florida right now. And knowing how to represent 3-digit numbers is super important because it allows students to really understand how numbers are built so that when they begin to add and subtract bigger numbers or decimals or fractions, they have a really strong understanding of how numbers can be broken down. So if we look at this number, 248, let's just talk about place value for a minute. So if I have a number with a decimal, I've got my ones place, I have my tens place, and I have my hundreds place. And then on the other side of the decimal, which we don't need right now, but always helpful to review, we have tenths and we have hundredths. And my iPad just shut off on me, but it didn't shut off on you guys. So we're going to keep talking about this problem. So if we look at this problem, we have, and there it goes, we have 2 hundreds, 4 tens, and 8 ones. So that first answer, A, would absolutely be correct because we have 2 hundreds, 4 tens, and 8 ones. And I'm going to reconnect my iPad here so that we can get going. Knowing that, and I'm going to multitask here, knowing that we can break the number down. So instead of 200s, I could take that 100 and break it down into tens. So technically, I could have 200s, and then I could take, or 100, I could take that extra 100 and break it into 10 tens. Here we go. We're back on it. Screen mirror. Sorry about that. Gotta love technology. It's connecting. All right, 200s, 410s, 81s. That's correct. But what I was saying is we could have 100. We could take the 10 tens from the 100 here and add them to here. And so I could have 14 tens and I could have 8 ones. That's not one of our options here, but it's definitely an option that could be represented on the exam. So knowing how to break that number down is important. 200 plus 4 plus 8. That's not going to be correct because the 4 is not represented correctly with the place value. So our place value is hundreds, tens, ones. We have 200. This 4 should be represented as 40. So this answer is incorrect because this should be 200 plus 40 plus 8, not 200 plus 4 plus 8, as evidenced by B. So A and D are both correct, but B is not correct. A and D are both correct, but B is not correct. We're going to take a look at C here in a minute. C was 300s minus 52. So I would literally just take the number 300, subtract 52, and then go from there. Is this live? I don't see any other viewers or comments. Yes, this is live. You may not see other viewers because they're on different platforms or they're on different Facebook screens, but there are other viewers here. So yeah, we are live right now, as evidenced by my technology failing on me. I don't know what's happening today, but that's okay. We're just going to keep going. So 300s minus 52, I can do 300 minus 52, and I'm going to get 248. So that's also a correct representation of 248. Therefore, letter B is incorrect, which means it's our correct answer because we were looking for the incorrect answer. All right, moving on. We are going to look at a very elementary version of a function. So this is good for pre-K through 12 people because this is going to show how a linear function is developed. A first grade class is measuring their plants for their living things unit. Below is one student's data showing how much his plant has grown. If the plant has consistent growth, how tall will the plant be on day 8? Consistent growth tells us this is a linear function. Now, for my K through 6 people, you don't need to know that this is a linear function, but for my middle school, high school, GK core people, that right there tells you that this is consistent, so it's linear. If it was not consistent, it could be exponential, it could be parabolic, it could be a lot of different things. But because it has consistent growth, this is a linear function. Because if we look at linear functions, I'm increasing the same amount every day or every hour or whatever that time frame is on my x-axis. So because it's consistent, we know this is linear. Okay, back to the problem. How tall will the plant be on day 8? Well, if we look at this, we have day 3, 4, 5, and 6. So really, I'm just looking for day 8. So if we have 3, 4, 5, and 6, I can solve for day 7 and day 8. How tall is the plant on day 3? 1 inch. Then it goes up to 2 inches, 3 inches, 4 inches. After that, what are we going to do? We're going to go to 5 inches, and then we're going to go to 6 inches. So therefore, our answer is going to be B, 6 inches, because we have consistent growth happening. Now, if it asked what is the slope of this, now this is going beyond K through 6, but I always like to address other things for my other people who are in this room. That's the extent of my problem for my pre-K through 3, K through 6 people. But my core, GK, middle school, high school people, it might ask you for the slope or for where the plant started, either one. So if we're looking for the slope, let's remember what slope is. Slope is going to be your rise over run. But if we don't have a graph that we can count our rises and our runs, then we can do y minus y over x minus x. Y is the y on top because that's your rise. Remember, our x-axis is right here and our y-axis is right here. So if this is my x-axis, that's my run. And if this is my y-axis, that's my rise. I'm going up and down, and then I'm running side to side when I'm looking for slope. So in this case, the day or the time is going to be x, and the plant height is going to be y, because the height is dependent upon the day. So if I wanted to find the slope of this graph, I could pick any of these points. It doesn't matter. I just have to have 2 points, because I have an x and a y and an x and a y. So I'm just going to pick this point and this point. It doesn't matter which points you pick. You're going to get the same thing. So I'm going to do 3 minus 2, because in this case, my points are 4, 2 and 5, 3. Because remember, these are my x's and these are my y's. So I'm going to do y minus y, 3 minus 2 over x minus x, 5 minus 4. I get 1 over 1, so my slope of this graph would be 1. It doesn't matter if you do 3 minus 2 or 2 minus 3. Whichever one you want first is fine, but you have to do that same x first. So if you did 2 minus 3, that's fine, just as long as you did 4 minus 5, and you would have gotten the same answer. As always, if you have questions as I'm solving these problems, please drop them in the comments. I'm more than happy to answer them. Also, if you have areas that you want me to focus on in the future of problems, please let me know in the comments. I'm more than happy to add kinds of problems into our problem sets each week. All right, let's go on to problem 4. Allison was given $75 for her birthday. She wants to purchase a doll for $32 and 2 outfits for her doll that are $14 and $23. If tax is 6.5%, will Allison have enough money to purchase the doll and the 2 outfits? This is a problem that's really straightforward. We just have to take this real life scenario and apply what we know. So what were we told? We were told that she was given a total of $75. That's the total amount she has. She was not given any more money. That was her total. Then it says she wants to purchase. Purchase obviously means that she's going to be using some of that money. So she's purchasing a doll for $32 and then 2 outfits that are each $14 and $23. The first thing I'm going to do is just add those numbers together to see how much she has spent just on the doll and those outfits. So 32 plus 14 plus 23. I'm doing this by hand. You might have a calculator, you might not. Depends on what test you're taking. Some people get one, some people don't. 4 plus 3 is 7. 7 plus 2 is 9. 3, 4, 5, 6. So far, she has spent $69 on the doll and 2 outfits. I always like to label my work because sometimes when these problems get to be really, really lengthy, then I don't want to lose what I'm doing or my work. So she's purchased the doll and the 2 outfits, but then it tells us that she has tax. It is not tax-free weekend. So tax is 6.5%. Will she have enough? How do I use that 6.5% to help me finish out this problem? Well, if this is what she has spent, I have to multiply that by that 6.5% to find out what that tax is. So I have to take 69 and multiply it by 6.5%. I'm not going to multiply it by 6.5. Why? Because that is not the decimal form of the percentage. Percentages, percents, fractions, decimals, and ratios are all just different forms of the same number. So I could literally take a percent and convert it into a fraction, a decimal, and a ratio. I could take a percent and I could convert it into a fraction, a decimal, and a ratio. So, and I would have the same number, just represented different ways. If I did 69 times 6.5, I would get 448.5. Does that number make sense in the context of the problem? No, it doesn't. I'm not going to pay $448, $448 in taxes on a doll and 2 outfits that only cost $69. So I immediately recognize I've done something wrong. I'm going to convert that decimal into a percent by hopping that decimal 2 places to the left. So I'm going to take this decimal and I'm going to go 1, 2. So I'm going to get 69 times 0.065 instead. And I'm actually going to flip those so that the 0.069 is on top and my 65 is on bottom. Now, if you have a calculator, absolutely do it with your calculator, please. Don't do it by hand if you have a calculator, because then we have less chance of making a silly error. I get $4.48.5, which is going to round up to 49. That said, what does that number represent? That is the tax. So I'm going to add that to my 69, $4.49. And I need to make sure that I line up my decimals correctly. So it's really going to be $4.49 over here. And when I add those together, I get $73.49. So what did we just realize? We just realized that if she had a total of $75, that she absolutely had enough money for that, for her birth, to buy the doll and the outfits. So yes, she will have enough money. How much will she have left over? $1.52. I didn't solve that. I just used common sense. I'm not going to waste testing time on that. I just used common sense to realize that 75 to 73.49 or $73.49 is not going to be $6. So I immediately chose A. If it was like, yes, she will have $1.52, or yes, she will have $1.54, I would have to solve that out. But in this case, I didn't have to solve that out. I could just use common sense and save myself a few seconds on that exam. All right, let's keep going. This is going to be K through 6, GK, Praxis Core, TExES. I mean, middle school, high school. Everybody needs to know how to simplify expressions. So, simplifying expressions, we are going to use order of operations. Order of operations is what we're using to simplify expressions. Now, what does the order of operations say? Order of operations is PEMDAS. Please excuse my dear Aunt Sally, where P and E are parentheses and exponents, M and D are multiplication and division, A and S are addition and subtraction. That said, we have to do them in order. But when we get to that multiplication, division, addition, and subtraction, those are kind of married. They're together. And you're going to notice that when we solve this problem. So I'm going to kind of put that in our back pocket, and we'll get to that in a minute. I'm going to zoom in here so that we can see it a little better. So if I know I'm using, please excuse my dear Aunt Sally, I'm going to look for parentheses and exponents first. In this situation, we don't have any parentheses or exponents. So I don't have to worry about either of those. Now, multiplication and division. When I get to this point, I see that I have both multiplication and division. And in this case, the division comes first if we read from left to right. When we get to the please excuse my dear, we do not have to do the multiplication before the division. In fact, we're not going to do the multiplication before the division. We're going to do whichever one comes first when we read from left to right. Only in this section right now. Okay? So I am not going to do 8 times 2, even though multiplication comes first in that saying. Multiplication and division are married, so I'm going to do the division first and then multiply. So I have 88 negative 40 divided by 8 is negative 5, because a negative divided by a positive is a negative. Negative times a positive is a negative. And then I'm going to keep everything else the same, times 2 plus 7. I still have 88, and I'm going to finish that section out, that multiplication division section out. So negative 5 times 2 is negative 10 plus 7. Now I've finished multiplication and division. I can move on to addition and subtraction. Again, addition and subtraction are married just like multiplication and division are married. So I'm going to go ahead and look for my addition and subtraction. And really, by the time we get to this point in the problem, we should only have addition and subtraction left. So I'm going to look at my problem, and I have subtraction and addition, but I'm not going to do the addition first. I'm going to work the problem from left to right because that's the direction that we read. So 88 minus 10 is 78 plus 7, and 78 plus 7 is 85. So our answer in this case is 85. Does that make sense? Like I said, we have to know order of operations, but keep in mind the chunks that are married or together that you can do left to right instead of in the order of operations. All right, let's keep going. A teacher displayed the image seen to the right on the board and asked students to find the perimeter of the shape. Which of the following answers reflects the correct, most simplified perimeter? All right, and in fact, little typo, this should be double there. Okay, so the first thing we know is that we're looking for perimeter. A teacher displayed this image and asked the students to find the perimeter. What do we know about perimeter and area? Perimeter is the outside linear border of the shape. Area is the square footage of that shape. So perimeter is a linear measurement. Area is a squared measurement. So if I'm finding the perimeter, I'm just going to add up all the sides of my shape, and that'll give me my perimeter. But you're asking me, Amy, how am I going to find the perimeter? There's not enough information to solve because we've got X's over here and not all of the sides are labeled. All of that is absolutely correct. We do have a bunch of X's. We were not given numbers, and not all of our sides were labeled. You're not wrong, but there's enough information to solve this, and I'm going to show you how. So let's erase all of that. So to solve this, I'm first going to look for congruency tick marks, which you see here. What that means is if I see one tick mark and then I see more tick marks that are just singular, that means all of these sides are the same. So that means if this is x minus 3, this is x minus 3, this is x minus 3, and this is x minus 3. Those congruency tick marks mean that those are all congruent, which also means that this is 4x plus 3. The only reason it has 2 is not because it's bigger or smaller. It's just to show that it's different from these right here. So the only reason it has 2 is to show that it is different than the measure of all of the other ones that have just 1 tick mark. Now I can just add all of these up and then simplify using our simplification rules. So I'm going to start here and I'm going to march around the shape. So I have 134 minus 7x plus 4x plus 3, because that's this side, plus x minus 3, plus x minus 3, plus 5 plus 2x, plus x minus 3, plus x minus 3, plus 4x plus 3. Now, why did I put those in parentheses? Because they are expressions. Now, does it matter if they're in parentheses right now? It really doesn't, because addition isn't going to change the value of those. However, if we were subtracting, it would matter, because then you would have to distribute that negative sign. So I'm going to go ahead and combine like terms here. So I'm looking for like terms. I have x, 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 and x. So I have 4x, 5x, 6x. Actually, I'm going to change colors here. I have 4x's, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14x minus 7. 14x minus 7x gives me 7x. Now I'm going to do my constants, because I cannot combine x's with constants. So I'm going to go ahead and look at my constants. I have 3 minus 3. That's 0. So I don't need to worry about that. Now I have negative 3 minus 3, which is negative 6. And then I notice I have another negative 3 plus 3, which is just 0. So far I have negative 6. And then I have a 134 here. Negative 6 plus 134. Or 134 minus 6. 134 minus 6 is 128. So I have 7x. I missed the 5 here. Look at that. 128 plus 5 is 133. So my answer is A. Now, some of you noticed there was a faster way to do this. If that made sense to you, hold there and don't do anything else. But there is a faster way to do this. Because I notice there are 1, 2, 3, 4 of those, I could have done 134 minus 7x plus 5 plus 2x plus 4 times x minus 3, because I have 4 of those. And then I could have done plus 2 times this one right here, 4x plus 3. And now there's a lot less expressions and terms for me to look at. So that's just one way that you could do it, or you can do it this way. If you do it this way down here, you would have to distribute this 4, distribute this 2, and then you would still get the same answer, 7x plus 133. All right, let's keep. Jason arrived for work at 9:20 a.m. and left work at 8:35. Jason gets paid $12 per hour and time and a half for any time he works over his 8-hour shift. if he takes a mandatory unpaid 30-minute lunch and mandatory unpaid 30-minute break, how much did Jason get paid? I see your question. I don't know your name because it's just showing me on my platform as Facebook user. I will go back to that and answer your question. That's a great question. I've already moved on, but I will go back as soon as I finish this problem. But I do see your question. The question is, why didn't I use the 134 first? Excellent question. I'll go back. Jason arrived for work at 9:20 and left at 8:35. So let's figure out how much time Jason worked first. So from 9:20, this is called elapsed time. This is something that right now we teach in 3rd grade in the state of Florida. If I'm going from 9:20 to 8:35, from 9:20 to 10:20 would be 1 hour. So if I put time on a number line, he starts work at 9:20, and then this is 10:20, 11:20, 12:20, 1:20, 2:20, 3:20, 4:20, 5:20, 6:20, 7:20, 8:20, 9:20. So he gets paid 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8. How many full hours does he work? He works 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 full hours. But then that's 8:20, and then he leaves at 8:35. How much time is that? That's 15 minutes. How do I figure out what fraction of an hour that is? Well, a fraction is just part over whole. Remember that. A fraction is just part over whole. Well, in an hour, how many minutes are there in my whole hour? There are 60 minutes in my whole hour, and he worked 15 of those. Well, what is 15 divided by 60? I'm going to see how I can simplify that. I can divide both by 15, and this is a quarter. So he worked 11.25 hours, or 11 hours and 15 minutes, which is equivalent to 11.25 hours, because a quarter translated into a decimal is 0.25. We talked about how you can transition percents, decimals, ratios, all of that earlier. So he gets paid $12 per hour and time and a half anytime he works over his 8-hour shift. So his 8-hour shift, he gets paid $12 an hour. So let's just figure out what he gets paid for his 8-hour shift. 12 times 8 equals, I should know that, but I'm not doing that in my head right now, $96. There's his 8-hour shift. But then he takes a 30-minute lunch and a 30-minute break. So how much time unpaid is he taking? He's taking a full hour unpaid. So now he's there for 11 hours, but he's only getting paid for 10 hours and 15 minutes. Following? So he gets paid $96 for his 8-hour shift, but now he's going to get paid time and a half for that extra over. How much time overage did he work? He worked 2 extra hours because his normal shift is 8 hours. So his overtime is going to be 2 hours and 15 minutes. And how much is he getting paid for that 2 hours and 15 minutes? Time and a half. What is time and a half? Well, it's a full time plus a half of it. So time and a half is going to be 12 is going to be your time. And then the half, what is half of 12? 6. So he's going to get paid $18 an hour for any overtime. So 2 times 18 is 36. But then how am I going to calculate what he gets paid for that extra 15 minutes? Well, if I know that it's a quarter of an hour, I can divide the 18 by 4 to figure out what that piece is. So 18 divided by 4 is 4.5. So this section is going to be $4.50. So I can add that to the 36 and I get $40.50. And right now I notice that there's only one answer with 50 cents. So I'm going to choose that one. If I wanted to doubly make sure, I could add the 96 to the $40.50 and I still get $136.50. But when I looked at my answer choices, I immediately noticed that 50 cents, there was only one answer with a 50 cents. All right, before I go into the next set of problems, I had somebody ask, how come I didn't start with the 134? I'm guessing you're asking, I'm not sure what you're asking. I mean, I kind of am. So in this case, I did not start with this 134 because I knew I needed to multiply first. Going back to that understanding of order of operations, I have to multiply before I add and subtract. So that's why I had to multiply here before I did anything. After that, I did not start with the 134 because I knew that everything was addition and subtraction. And I knew I needed to add my like terms together. And 134 plus 3 minus 3 minus 3 just seemed more cumbersome to me than doing all of my threes and then adding that one number to the 134. If you wanted to start and do 134 plus 3 minus 3 minus 3 plus 5, that's totally fine. It really doesn't matter if you start with the 134 or not. Down here, it's important that you multiply first, but then after that, it doesn't matter what order you add them in, really, because addition is commutative. So you could have added the 134 first. That was a really good question. All right, let's go into a little bit of high school only. So this question is very specific to my math 6 through 12, 7 through 12 people. An object is traveling through space with a velocity of v of t equals 5t plus 4. What is the particle's position at t equals 2 seconds? Like I said, this is for my middle school and high school people, or really my high school people only. This is calculus. All right. Velocity, position, and acceleration. So if I have a particle traveling through space, then my original function is going to be my position function. So my original function, p of x, is going to be position in relation to time. Then, if I take the first derivative of that position function, I get my velocity function. And then if I take the second derivative, I get my acceleration function. So in this case, an object is traveling through space with a velocity. They gave us the first derivative of the position function. And they want to know what the particle's position is at 2 seconds. Well, if I'm going this way, I'm doing derivative. If I'm going this way, I'm taking the integral. So because I have my velocity function and I'm trying to get to my position function, I'm going to take the integral of this function using the power rule. So I know that the power rule says I take my exponent and I drop it. In this case, I'm going to take this and make it my exponent. So this would become t to the 5th power. And I totally made an error when I built this problem. So we're going to pause on this because when I built this problem, I know how I solved it, and these answer choices aren't going to work. So high school people, we're going to table this problem. I promise it'll be the first problem we do next week. And then we're going to do velocity, acceleration, and position all in one. But I don't want to solve this incorrectly. And I know how I solved it. And the way that I solved it gave us drastically incorrect answers because I was making this up in my head. And so we're going to table this problem. I'm going to do position, velocity, and acceleration first next week. And then we're going to go into a geometry special. So I'm going to do all of these problems I built the same way. So we're going to talk about position, velocity, and acceleration next week. And then we're going to go ahead and look at geometry problems. If there's something else that you want to see from me next week or the following week in these sessions, please let me know. Is it lines? Is it parabolas? Is it patterning? Is it solving word problems? What do you want to see from me as I begin to build out the problems for the rest of the month of March? I don't know. I'm waiting on you to tell me. Otherwise, I'll just keep building problems. Next week, we are going to focus on geometry. So thank you so much. We're ending a little early because I botched these problems. So we're going to do these next week, and then we'll do geometry. Thank you so much for spending your Wednesday evening with me. Remember, we're here from 6 to 7, not 7 to 8 moving forward. I'm going to turn it back over to Dr. A. He has a special little coupon for you, and then I will see you next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidge of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.